Object-oriented programming relies on three pillars, namely encapsulation and abstraction, inheritance, and polymorphism. Python, being object-oriented programming language, supports these three pillars. In this chapter, we will learn how to create a class, how to create the instances of class, and how to define attributes of a class, and how to access the attributes of a class in expression as well as in function calls, and how to send an instance to a function as well as how to return an instance from the function. Also, we'll be learning how to create the object references as well as how to create the copies in different ways. Before getting into the actual chapter contents, let us understand the one of the important concept in the language design called a binding. The binding is a process of associating the data type to a program element. It means that the attaching of the data type to a variable or an object or any other program elements. And this binding can take place at different times, either at programming time, during the assembly, at compile time, at runtime, or even at loading time and linking time. Most of the languages adopt the compile time binding, that is also called as a static binding, or few of the languages adopt runtime binding called dynamic binding. Let us understand the binding in compile languages. For example, we'll take up a C language or a Java or a C#. Every variable is attached with the data type, either the integer, float, or character, or whatever, by the compiler. That is called a static binding because the compiler associates the data type to a program element while generating the object code or object file. For example, if we have a statement like this, float a, so this is a declaration statement in a C language. It means that the compiler attaches the data type float to a program element a during compilation. That's why it is called compile time binding or static binding. Let us take up the binding in interpreted languages. All the interpreted languages use a dynamic binding. It means that the attaching the data type to a variable or to any other program element is done at program execution, that is at runtime. For example, if you take up the statement in Python, a is equal to 5, at runtime associates the type integer to a that is based on the value 5. Similarly, if we write a is equal to 5.0, then at runtime the Python runtime environment attaches the data type float to a variable a depending on the value, that is 5.0. Similarly, if we write b is equal to 3.2, the Python language runtime associates the data type float to a program element, that is a variable b, based on the value, that is 3.2. Since the Python is an interpreted language, the Python binds the program elements at runtime. It means that Python follows the dynamic binding, and this is very crucial in understanding the concepts of class and objects in Python. Programming languages provide the facility for the programmers to create user-defined types like structure, union, or a class. And these user-defined types facilitates the programmer to create new types, that is user-defined types, by encapsulating the existing types or even the derived types. Python, being the object-oriented programming language, facilitates the programmer to create a class or an object template which can be used to create the user defined types or to create new types. Class in Python. The class in Python is a programmer defined type or a user defined type which is created with the keyword class. And in Python, class is also called as a class object because the Python runtime allocates memory to this class type. If you take up the compile language like C, C++, Java, or C#, the memory will not be allocated to a class definition. It becomes a template to create the instance. But since a Python is a interpreted language which uses the dynamic binding, it creates the class object representing the class in memory. Thus the class object or a class has got a memory address as well as the memory layout. Now let's understand how to create a class or a class object in Python. We don't have to specify the members. This is a first format of a syntax. We have to specify the class keyword, class followed by name of the class, colon, and we have to use an indentation with this docstring. What is this docstring? Docstring explains the purpose of a class as well as the number of attributes that a programmer wants to include in a class. And this is the header, class header. Class header indicates the name of the new class or class object. And remember, this docstring is optional. This is not a mandate. And we have one more syntax. We can even specify the members as well while defining a class. So this is the syntax, second format, class with the class name colon, and we can define number of data members with the member equal to value. The value is a must because we are not specifying a data type like a compiled languages. It is a dynamic language, interpreted language. We don't associate the data type. The data type is associated based on the value. That's why this value is mandatory. And we can also specify the member functions in the class. Let's take up one example. Let's create a simple type, user defined type called point, which represents the point in a two-dimensional space. We use a first format syntax, class point. This is a class name or a class object, and this is a docstring. It specifies this class represents 2D space. And by writing the class point, a memory is allocated to this class called point. That's why we call this as a class object. We'll take up the second example with for the second format. Here we specify the members also. Class point docstring, this is optional, and then we specify two members. One is x with the value 0 and second y with the value 0. Here defining a class name point creates a class object with two members or two data members or attributes with the values x is equal to 0 and y is equal to 0. And if you print this point, we get this result, class underscore main underscore point, because the point is defined at the top level. That's why the name of full name of this point is main underscore dot point. Main underscore dot point. In order to access the attributes like x as well as y, we have to use a period operator or dot operator to access the attributes of an object. You can also add attributes at any point of time by using this dot operator. So far we had only two attributes x and y. We can add one more attribute to a class called point by writing point dot z equal to 0 or z equal to any other value. Remember, this adding member should happen before any instance creation. Once you create an instance or an object of a class, later on you are not allowed to add attributes to a class. So adding of attributes should happen before the instance creation. You can also change the value of data members at any place within the program with a simple assignment on the right hand side. So left hand side, class name dot attribute name equal to value. This will assign a value 2 to x instead of 0. How to create objects of a class in Python? We know that object is an instance of a class, and the process of creating the objects from a class is called instantiation. And the syntax in Python uses a simple assignment statement which takes the form object name equal to the class name with open and close parenthesis. This is a default constructor. If we use parenthesis with no argument, it's a default constructor of a class which creates an object in memory and returns the reference to the left hand side, that is object name. Again I repeat, object name equal to class name with the default constructor notation, allocates the memory and returns the reference, that means the information required to access that memory to the left hand side, that is to the object name. Let us take up one example. We have defined a class point with x and y, and we now create an object called blank. Blank equal to point with the default constructor notation. This creates an object in memory and returns the reference to the variable, that is object variable blank. And if you print this blank, we will get the information related to the object called blank, as it is derived from the class called point, and this is the full name, that is underscore main underscore dot point is the full name of that class point, and the memory allocated to this object blank is at 0x b7 etc. So 0x refers to hexadecimal address notation. Object state. The set of values of attributes of an object is called as a object state. Let us take up one example to understand the concept object state. As I said, object state represents the values of the attributes present in an object. We'll take up the class called point again with the value x and y with 1 and 3 respectively. We just print the attribute with the dot operator. That means we access the attribute x through the class object directly. Now we have not created any object now. When we create a class point, it creates the class object called point in memory. That means x and y are stored in memory. That's how we can access the values of x and y, because they are stored in memory. Point, this is a class name dot x returns me 1, the value. Similarly, point dot y returns the value 3. And now we add one more attribute, that is z. It is allowed now because so far we have not created any object of point. It is allowed. Point dot z. So that z is a new attribute that is being added now. Point dot z is equal to 5, and let's print the value. The value of point dot z is now 5 because the point dot z is assigned with the value 5. We can also modify the value of attribute y through a simple assignment. Left hand side we have to write the class name or class object name followed by dot operator and the attribute name equal to the value that you want to assign. So this is possible. You can assign and you can print. And altogether you can print the values of all the attributes x, y and z, and the values of all these x, y and z is nothing but a state of an object at a particular point of time. The values are right now 1, 2 and 5 because 3 is being changed to 2. Ultimately this is a state of the object at this point during execution, that is 1, 2. We'll take up second example. We have a class, same class definition, point with x and y with values 0 and 2 respectively, and we add one more attribute z to the same class point with the value 3, and now we create the object with the name p. Remember, now p has the value x, y and z as 0, 2 and 3 because it is the instance of the class object, that is point. Let me assign a value to x of object p dot x is equal to 1, and let me print these values p dot x, y and z of p. We'll get the result 1, 2, 3. 2, 3 are already the values available in p because of the instance of class object point, and we have assigned the new value to attribute x, that is 1. Ultimately we get value 1, 2, 3, and you can also print the value of that class object or a class. It remain unchanged because the Memory for point, that is a class object, is different, and memory for P is different. Let me create one more object, that is Q, and I'll assign the values 10, 20 and 30 respectively to X and Y and Z. And let's see, we print the value of X and Y and Z of Q, 10, 20 and 30. So this is the state of this object Q at this point during execution, and this is the state of the class or a class object at this point, that is, it remains same, 0, 2 and 3. Now we will see how to pass the objects as function arguments and how to return the objects from the functions, as well as how to use the attributes in expressions. In order to use an attribute in an expression, we have to use the dot operator along with the object name as part of any expression. As an example, assume that we have an object P with X and Y values 1 and 2 respectively. To access these values and to print, we are using the dot operator P dot X and P dot Y, and this G is actually general format, and this parenthesis is used to print the X and Y as in a mathematical notation of a point with 1, 0 and 2, 0. And this is also one form of expression which is found in the print function. We can also use the attributes in arithmetic expressions as well as other expressions. Here is an example. We have used this attribute in the arithmetic expression. We are taking square of the points, and then we are taking the square root of x square plus y square, and once we print this, the value distance, we get 2.2 and 3. This is how we can use these object attributes in an expression with the dot operator. We can also pass the object as an argument to a function like this. Assume that we have a function which is defined as a print point, which takes the object, and the body of this function is just to print the contents of the object, that is attributes of the object. This is how we can pass the object to a function, and this pt is the object variable which is found in the argument and which is to be used to access the individual attributes of the object. And how to call this same function? We have to create the object P somewhere in the main, and then pass this object P to a function print point. And now this object P will not be passed to PT, rather the formal argument PT, which is found in the function definition print point, becomes the alias or a reference to the actual parameter P in the function call. So this is a function call, and this is the actual parameter, which is the object P. And when we call a function with the object as a parameter, the argument in the definition of the function becomes the alias to the actual parameter that is found in the function call. It means that whatever the changes that you make within the function through the object, the formal argument pt, will change the value in the actual parameter object p accordingly. We'll take up the example to illustrate this. Let me redefine this same function print point just for this example. As we read the object through an argument pt, and then we modify the value of x to 3, and if we call this function like this, like print point p, and after this call, if I print the value of x, the value of x is 3, because pt and the p points to the same memory location. The argument pt is a alias, is a new reference to the same object p, and whatever the changes that you make through pt affect p also, as both p and pt points to the same memory location. So you need to remember this whenever you pass an object to a function. The argument that is found in the function definition is an alias to the actual parameter, that means the object that you are passing, and any changes made within the function to the individual attributes of the argument of the function will change the actual argument also. Object state can be changed at any point of time by changing the values of attributes. Thus, we can change the state of an object at any point of time during the execution of an application. Thus, we say the objects are mutable. It means that the object state which can be changed at runtime by changing the values of individual attributes. To illustrate this, we will take up a function change point. Is takes one argument, which is an object, and we increase the value of x by 2 and y also by 3, and then we print. And in the main, we create an object point p, and we initialize this object with x is equal to 1 and y is equal to 3. So here p equal to point creates an object, and object p, and p has a state with the values x is equal to 2 and x is equal to 0 and y is equal to 2, as per the definition of a class point. And now we are changing the state of this p by explicit assignment. We are assigning the new values to the attributes. This is how we can change the state at the main. Similarly, we can write a function to change the object state by passing the object itself as a function parameter. That's what we do here. The change point p, where p is passed to a function, and here the values x and y, that is the state of the object p, being changed through the pt. Pt is the alias to p, and we are changing the value of x and y through pt, which affect the p also. And ultimately, we get the values x is incremented with 2, that is 3, and y gets the value. We can create objects in a function, as well as we can return these created objects from the function. To illustrate this, we will take up a function, a midpoint, which creates the midpoint of 2 points, wherein this function takes 2 arguments, that is 1 and 2, which represents the object 1 and object 2. And you can see here the mid equal to point. We are creating a new object in the function, and then we assign a value to this new objects with the property attributes of this object x and y accordingly, by taking the average of values of x of 1 and 2, as well as the average of y values of object 1 and 2, and this becomes the state x, the new values for a point, that is x and y values become the state of this new object that is created in the function. And how do we return this object? Like a simple return the object name. This will returns the object that is created within this function midpoint. So this is the class definition, where we initialize a point with x and y, and we'll create the object here in the main. P is equal to point, and then we assign the new values to x and y, and we create another object q with the values 1 each, and now we call a function midpoint of p and q. So this is the p with 2 and 2, and this is q with 1 and 1. That the state is being passed to a midpoint. Midpoint is this, which takes these 2 objects, and this function will create a new object with new values and returns. So ultimately C is a now the alias. C is a now alias to this mid. So this object is being created in the function, and that object is being returned with this function call, and ultimately that is being assigned to C. And we can see that now C is an alias to the object mid, and whatever the changes that you make through the C will affect the mid also the same, because both the points are the same memory location. Now we can print the values of x and y with through the object name C in the main function. We get 1.1. The class definition can take attributes which are the instances of other classes. It means that we can have an object as an attribute within another class definition. To illustrate this, let us take up the example of creating the rectangle object. We can design a class to represent the rectangle like this. We require 3 attributes. One is the corner, either lower left side or the top left side. We require one corner point representing x and y, that's the coordinates. Then we need second parameter is attribute a width of the rectangle, and the third parameter is a height. With these 3 we can define a class called rectangle like this. We define a class rectangle, and this is a docstring which explains the members of the class rectangle. It says that it has 3 attributes. One is width, height, as well as third is a corner, which is a very composite attribute which requires the 2 data values, that is the x and y. To represent the rectangle, we create the rectangle object. First, box is equal to rectangle. We create an object box with the class rectangle. And now we assign a value to a first attribute, width. Box dot width is the first attribute with 100. Then second attribute, box dot height with 200. For the third attribute, we have to create the object point because we need to store the values of the attribute corner. We define that as box dot corner. So this is attribute, and this point equal to point with the default constructor creates the object point, and it just returns the reference. So ultimately box dot corner is now attribute which holds the reference to the object that is created. How to add the values of x and y of that newly created object point? You have to use the reference, object reference, that is box dot corner refers to the reference to the point object, dot x equal to 1.0. Similarly, you can assign value 2 to the attribute y. Remember, the attribute box dot corner is a reference to the object that is created somewhere in the memory. Now let us print the box object. You can print the width with the object name, that is box. Here is a directly class name. We have not created any object. Box is a class object. Dot width will gives the 100. Box dot height gives me the 200, and to get the x and y values you have to write box object dot corner. So this is the attribute. Corner is the attribute of a box, and this actually attribute holds the reference to the point object that is created, and wherein you can use the dot operator to access x and y accordingly, and this gives the result in the mathematical notation 1, 2. So this is how we can make the instance of a class as an attribute in another class, and you can access them through the association operator, that is through the dot op. Assigning one object to another variable, that means creating an alias, normally makes a program difficult to read in terms of understanding the logic, because the changes in one place to an object have unexpected effect in other place within the application or within the program. That's why it is very hard for the debuggers or for the programmers to keep track all these variables that might refer to a given object. Let us take up one example to illustrate this the unexpected effect. Assume that we have a class called point with x is equal to 0 and y is equal to 0. This is what the class point is being defined, and if you print these values we get 0, 0. Let me create one object that is p, which is nothing but an reference. Remember, you don't find here a default constructor notation. It means that I am assigning this class object directly to p. This is what the meaning of assignment of an object to a variable. P is also an object variable. Point is also class object variable. So now P and point points to the same memory location. And let me change the value of x to P. I'll change P dot x equal to 1. And let me print the values. I'll get values 1 comma 0. It is x is changed, that is 1 and y is 0. Let me create the object now. Now I am creating object and I am interested in to create an object Q with the values 0 and 0. But what is the result I am going to get? If I print the Q dot x and y, I get 1 comma 0, which is unexpected. As a programmer, I wanted a Q should have a value 0 comma 0, but I am getting 1.0 because of this alias, that is P being created and then value of x is being modified through P, not directly with the class object point. So this is one unexpected, undesired result that we get. Assume we want to create one more reference. Now what I am doing is I have a P, I am creating one more alias to P, R equal to P. That means now I have a 3 object variables references refer to the same memory. One is a point and then P as well as now R also refers to the same memory location. And now I change the value of x through R. You just imagine the complexity. I am not touching even P. I am just changing now the x through R, and you see the effect. And here I am creating one more object and I am expecting the values x and y to be 0 comma 0, but I am getting 2 comma 0 because through P x has been changed as well as through R also x has been changed to values of y, and ultimately I get a unexpected result 2 comma 0 instead of 0 comma 0. This is the difficulty of understanding the program by the other readers of the program or by the debuggers. If the programmer wants to create the multiple copies of an object, then the programmer has two options. One is to create the aliases, and we understood the problem of having aliases to an object. It decreases the readability of the program or the code. To avoid this problem, the Python provides a second option called a use of a copy module, and we will see how copy module can be used to create the copy of an object. Not only a single object, we can create multiple objects. And the first function that we have in this copy module is called copy.copy, which creates a duplicate of an object. And this copy is called as a shallow copy because it creates just a copy of this existing object. For example, if an object contains the reference to another object, it creates a copy of an object with just a reference as an attribute. It will not copy the object itself. That's why the word shallow. It won't copy the object that are referred within the object. We'll illustrate this shallow copy in two different examples. We create the object P1 of point and we allocate values 3 and 4. Now we have to import the copy module before using this function copy. And now I will create a copy of P1 with a simple assignment P2 equal to copy.copy of P1. So this argument P1 is the source object, and this is a new copy that is being created for me. And you can print the contents if you just write print point. If you have a function called print point which prints the x and y values, and if you pass P1 you get the values 3, 4, and if you pass P2 again you get 3, 4. Remember, P1, P2 are now different objects. This is not like P2 equal to P1, what we did earlier. P2 equal to P1 is nothing but we are creating a alias P2 for the P1, and it has got a unexpected results in the later sections of the program. But if we use copy.copy, it creates a separate copy, and P2 is a separate object in memory, and P1 is also separate object in memory. And if you change the value of x of P1, doesn't change the value of x of P2. Let me check the equivalence and identity of these two objects. So is an operator to check whether the objects are identical, and if we execute this print P1 is P2, it returns false because they are not identical objects, they are separate objects. If I had written P1 equal to P2 or P2 equal to P1, if I had created P2 alias for P1, then if I write like this, I get a value true because P1 and P2 refers to the same memory and they are identical in terms of values as well as in terms of reference. And what about the equal? Again, this is false. P1 is separate because they are not identical. Definitely they are not equivalent. That you have to remember. The objects which are identical need not be equivalent, and here it is not, the objects are not identical, definitely they are not equivalent. So that's why we get the results false and false. We'll take up one more example. We'll apply this copy to duplicate the rectangle object. And we know that rectangle object has three attributes. One is a width, height, and third is a reference to an object, not the object. It is in reference. Let me create the second object, that is box2, by writing copy.copy box, and if I execute this box2 is box, I get a value false. Yes, box2 is a separate memory and box is a separate memory. And let me check the attributes. Box2 corner is box corner. Yes, it is true, it returns true because both the attributes, that is a references, box2 corner and box corner, refers to the same object of point in memory. That's why it returns a value true, because both these attributes refer to the same point in memory. That's why we call this kind of a copy as a shallow, because it copies the object and any references it contains, but not the embedded objects. It means that it copies the members of a class. If a member is a reference, just copy that reference, not the object itself. So this is how the shallow copy is being described with this diagram. As we created a box with 100 and 200 and the corner with 0 0, then we use the copy.copy to create box 2. Yes, separate copy is created in the memory, box is a separate memory, and point is being created while creating this first box separate memory, and that reference is being returned here. And now the copy will create another copy with identical with different attributes of width, height, and but corner being referring to the same object of point that is being created with the first object, that is the class object box. That's why we don't find multiple copies of that point object x and y. The problem with this is, if uh, you want to change the value of y for box, you don't want to change it for box 2, you cannot do it because you have only single copy, and whatever the changes that you make to x and y, you want to change the corner, let us suppose, will change the corner of box 2 also, because they share the same memory space. So this is what the most of the applications don't want, this kind of effect of members being uh, members of different objects being sharing a common object, which again creates a confusion and other errors which is related to the business logic. For this, to avoid such kind of situations, the Python provides another mechanism called creating a copies with a deep copy method. This deep copy method, as I explained in the previous slide, copies not only the object members attributes, but also the objects that are referred by the members or the attributes. And this is actually recursive in nature. That's why we call it copies all the objects referred through a reference chain. Ultimately, we get totally multiple copies, and individual member or attribute is totally a self-contained object. There is no reference. That's why this operation is called a deep copy, as no object is being shared among the copies that are created through this deep copy method of the copy module. Let's take up the same example of box. Here we, instead of using copy.copy, we just use a method copy.deepCopy. We have created a box 3, and let us check whether the box 3 is box. Identity, yes, identity is totally different. Box 3 is a different object, and box is also different object. We get a false. We'll check the identity of the attributes. Box 3 corner is box corner. In the previous example, we found the answer true because both the attributes refer to the same object in the memory. But now box 3 corner as a separate object and box corner is totally separate. That's why I get the value false. By these two methods, the programmer can create the multiple copies of an object without any confusion and any ambiguity. and the programmer can choose either to have a shallow copy of the object, or a programmer can even have a deep copy, and the selection is purely dependent on the scenario that appears in the application development. These are few review questions for the self-assessment. In this slide, there are two exercise programs. First program is to define a class representing the length, meters, centimeters and millimeters. Thereby you can develop a program to create the objects representing heights of two persons, and then you can calculate the difference in their height by giving a suitable message. Second program requires a function to be defined which takes two objects representing the complex numbers and to return a new complex number by adding these two complex numbers. Complex number normally takes two parts, the real part and the imaginary part. So one need to define two attributes for a class called complex to represent a complex number. Thereby you can develop a program to read n complex numbers by reading their real part and imaginary part, and then call this function, complex addition function, to add these n complex numbers and to generate the result. I request the learners to go through these two links for more information on classes and objects in Python. Thank you.